Ever wondered how your phone knows it's going to rain at 3 p.m. tomorrow? It's like your weather app can see into the future. But how do meteorologists get such precise information about something as unpredictable as the weather? Today, we're diving into how weather forecasting works, what kind of data is involved, how technology has made predictions way more accurate, and why the longer the prediction, the shakier it becomes. Let's crack open the science behind this and see why sometimes it feels like Mother Nature is working with, or sometimes against, your local weather team. First things first, to predict the weather, you need data, and a lot of it. Imagine if we tried to predict the weather just by looking out the window. We'd have no idea what's happening in the next city, let alone halfway across the world. Weather forecasting is like trying to solve a massive puzzle where the pieces are always changing. And to put that puzzle together, meteorologists collect data from multiple sources. Weather stations. These are scattered across the globe, measuring things like temperature, humidity, wind speed, and barometric pressure. There are over 10,000 manned and automated weather stations worldwide, collecting data every hour. Satellites. These orbit the Earth, giving us a bird's-eye view of large-scale weather patterns. Satellites can measure things like cloud cover, sea surface temperatures, and even track storms as they form. They capture images, but they also collect infrared, microwave, and visible light data to map out conditions from space. Weather balloons. These balloons are launched twice a day from over 900 locations around the world. They carry instruments called radiosondes that measure temperature, pressure, and humidity as they rise through the atmosphere, providing a vertical snapshot of what's happening at different altitudes. Radar systems. Ground-based radars are used to track precipitation, like rain, snow, or hail, and even the movement of storms. Doppler radar can tell meteorologists how fast precipitation is moving and in which direction, giving them a better idea of storm intensity. Buoys and ships. In the ocean, we have buoys and ships collecting data on sea surface temperatures and wave height. This is especially important for predicting storms and hurricanes. So what's the end result? Billions of data points are collected every single day. We're talking about several terabytes of data daily. Imagine trying to store and analyze that much information. This data is essential because it gives meteorologists a real-time view of what's happening in the atmosphere. Now here's the fun part. How do we turn all of this raw data into a weather forecast? This is where supercomputers and advanced algorithms come into play. When meteorologists want to predict the weather, they feed all this data into numerical weather prediction models. Think of these models as the world's most complex jigsaw puzzles. Each piece of data, whether it's wind speed in one city or cloud cover from a satellite, helps to shape the bigger picture. But instead of manually piecing it all together, we let supercomputers do the heavy lifting. To give you a sense of scale, the European Centre for Medium-Range Weather Forecasts, ECMWF, runs one of the most advanced weather prediction models in the world. Their supercomputer processes about 20 million billion, yes, you heard that right, calculations per second and consumes as much electricity as a small town. Each weather model run can produce more than 100 terabytes of data. That's like streaming HD movies nonstop for over a year. These models simulate the atmosphere, breaking it down into a 3D grid of tiny boxes, often called grid cells. Each box represents a specific area of the Earth's atmosphere, its temperature, pressure, wind, and moisture. The models then use physical equations to simulate how the weather will evolve over time in each of these boxes. The end result is a forecast that tells you what to expect in terms of temperature, precipitation, wind, and more. Think of it as lining up dominoes. Each data point we collect is like placing a domino in a long chain. The current state of the atmosphere is one of those dominoes, and the computer models tell us how the next one will fall based on the laws of physics. As each domino tips over, it affects the next, and so on. This is how weather systems behave. If you've set the dominoes up perfectly, you can predict exactly where and how they'll fall. But if you misplace even one, things get a bit messy. This is why weather predictions for tomorrow are usually spot on, but forecasts for next week get fuzzier. Small errors in the data multiply over time, leading to uncertainty. Thanks to advancements in technology, today's weather forecasts are far more reliable than they were just a couple of decades ago. Here are some of the reasons why. 1. Better data collection. We now have more sensors than ever before. from satellites and weather stations to even data from commercial planes. With more data points, we can create a more detailed picture of the current atmosphere. 2. Supercomputers. These are the real MVPs of weather prediction. As mentioned earlier, supercomputers can crunch billions of numbers in just a few seconds, allowing us to run simulations faster and more accurately than ever before. 3. More sophisticated models. Weather models themselves are constantly being improved. Scientists tweak them based on real-world data and past forecasts to make them more accurate over time. 4. Ensemble forecasting. This method involves running multiple weather models with slightly different starting conditions to see a range of possible outcomes. It's like rolling a pair of dice 100 times and seeing which numbers come up the most often. This gives meteorologists a better sense of how confident they can be in their predictions. Now let's talk more about why the confidence level of a weather forecast changes over time. Predicting the weather is relatively easy for tomorrow or the day after. In fact, the accuracy of a 24-hour forecast is about 90–95%. But as we push further out, say 5 or 10 days, that number drops significantly. This happens because of something called chaos theory. The atmosphere is incredibly complex, and small errors in our measurements today can lead to big changes later on. This is often referred to as the butterfly effect. The idea that a tiny change, like a butterfly flapping its wings, could eventually lead to massive consequences, like a storm on the other side of the world. In weather forecasting, this means that if there's even a small error in today's data, it will get magnified over time, making a 7-day forecast much less accurate than a 1-day forecast. By the time you're looking at a 10-day or 14-day forecast, the confidence level has dropped to around 50–60%. That's why these long-term forecasts are more about spotting general trends, like warmer than average or chance of rain, rather than telling you exactly when and where it'll rain. Let's be real. Weather forecasts don't always get it right. And when they don't, it's usually due to one of 3 things. 1. Data gaps. While we have a lot of sensors, there are still areas, like oceans and remote regions, where we don't have as much data. Fewer data points mean more room for error in those regions. 2. Sudden atmospheric changes. The atmosphere is constantly shifting. Sometimes a storm system will change speed or direction, or a cold front might move in unexpectedly. Even the best models can't always predict these sudden shifts. 3. Complex phenomena. Some weather events, like tornadoes or thunderstorms, are tricky to predict precisely. We can forecast the conditions that might lead to them, but pinpointing exactly when or where they'll happen is still a challenge. In the end, weather forecasting has come a long way. Thanks to supercomputers, satellites, and more data than ever before, we're able to predict the weather with impressive accuracy, especially in the short term. And while it might not be perfect, especially for longer forecasts, technology is constantly improving, meaning your local forecast will only get more reliable in the future. That's it for today's episode. Next time you check your weather app, remember all the science, technology, and terabytes of data that went into predicting whether you'll need that umbrella. Take care, and see you in the next episode.